Exercise 2.7 is one of those little exercises that do not lead to an application that has actually a useful purpose, but rather allows you to play with some features of the language in order to understand them better. So when you are learning a programming language, normally you are reading a book and you have next to you a laptop or a desktop with sufficient software to test little programs like that in that language. This is the only way that you can actually learn really a programming language. So the kind of exercise we're going to tackle together right now is the kind of exercise you do typically while reading a book about a programming language, just to make sure you understand how things are working. Tiny exercises that illustrate a specific property of the language. So what are we trying to achieve in this exercise? Well, the purpose of the exercise is just to take a variable containing an uppercase letter and convert it into a lowercase letter. So that's easy enough to achieve. Okay, I can have a variable named uppercase of type char. I'm going to assign it a character. So remember, character literals in Java are single quoted. So anything I'm going to put in between those single quotes, any single character I'm going to put between the single quote is going to be actually a character for Java. So there we go, letter A, character A. These are the notation you need to understand and be familiar with. Okay, so I have my variable containing an uppercase character. Now the idea is I want to transform it into a lowercase character by using the property that all characters in Java are indexed. Each character is represented internally as a number which correspond to a subscript in a table. So the most ancient table used to store character and reference them was named the ASCII table, ASCII. Nowadays most programming languages are using Unicode as a way to represent characters, so that it allows them to represent many more characters, including Japanese kanji and stuff like that. So the good news is that between the ASCII table and the Unicode codes there is a compatibility. The first 256 characters of the Unicode table are the same as the ASCII table. So we can pretty much still reason thinking in terms of ASCII table when we are actually converting character from uppercase to lowercase. How do we do that? Well, knowing that characters are represented by their index in the table, if we can assess what is the difference between the index of uppercase A and the index of lowercase a, then we can subtract this offset, to any uppercase character to transform it into a lowercase character. So we are going to compute this offset. For this we are going to have a little variable, a lot of typos here, int offset, and this offset is going to be the difference between the index of character A and the index of character A. These are character literal. Okay, so trying to subtract character literals depending on the programming language can go more or less nicely. So what we're going to do to avoid the compiler complaining is to have an explicit typecasting here, a type conversion, okay, using this operator here, which consists of a parenthesis, closing parenthesis right before the value to convert, and in between the parentheses the name of the type you want to convert this value in. So this reads here explicit casting, explicit conversion of the value character A. So character A is a character obviously internally represented as a number. Well, I'm trying to make it explicit that I want to access the number which encodes character lowercase a. So this minus that is going to give us the offset between the two. Once we have this offset, what can we do with it? Well, let's declare a variable lowercase, okay, in which we are going to store our uppercase variable converted. So how do we do this? Well, we are going to take uppercase, okay, and we are going to add to uppercase the offset we just computed. However, uppercase, what is the type of uppercase? Uppercase is a variable of type char. So to make like addition, subtraction, etc., I'm going to once again do an explicit type conversion to make sure that I'm using here the integer which represents the character stored in uppercase. To this integer I'm going to add an offset. the offset in the ASCII table. And then what is going to be the result of this whole expression? An integer. And I don't want an integer because I'm trying to store the result of this expression into a char variable. So once again, explicit type conversion. Now a quick remark about all those explicit type conversion. Explicit type conversion do not do miracles, okay? You cannot try to fit an entire employee record inside of an int variable and expect that everything is going to be working fine, okay? If your employee record is a data structure containing a name, a social security number, etc., trying to assign it to an int variable is always going to be a problem because you have a lot of information that will be lost. In this case, however, everything works fine. Why? Because we are juggling between two representations of the same thing. A character is represented internally by an int value. Okay, so when we manipulate characters, we can convert them into int. What is going to be the result of this conversion? Their index in the ASCII table. When we have a small integer value and we want to convert it into a character, we can take this integer value and typecast it into a char. What is this going to do? It's just going to use that integer value as an index in the ASCII table, and the resulting conversion would be the value of the character at that index in the ASCII table. So we can move back and forth here really easily in this program between characters and integers only because there is a strong relation between those two representations of the same thing. Okay, otherwise we would not be able to do that at all. Now, what do we have left to do in this program? System.out.println, and we are going to say that uppercase, I'm going to display here the content of variable uppercase A, for example, in our example, is lowercase, and I'm going to display lowercase here. I'm going to restructure this so that it's a little easier to read. Okay, there we go. I'm saving, and we are going to test this program. So I'm going to go back to my Conqueror window, Java C exercise 2.7.java. Compilation worked fine. Java exercise 2.7. Uppercase A is lowercase a. Is that enough for me to be satisfied with my program? Well, I would say watch out. We can compute it in an offset using uppercase A and lowercase a. Our uppercase letter was big A, so there might be like some error here that we're not catching because we're not testing different things that are different enough. So let me try with Z, for example. Save the program again, compile it, run it. And okay, there is a little glitch here because apparently the file didn't have time to save properly. I'm going to double check here, Control S again, and I'm going to recompile. So I made sure again that this program was saved correctly. I'm giving it a couple of seconds. I'm going back to the Conqueror window, and I'm going to compile again, run again. Uppercase Z is lowercase z. Let's try once more to make sure. I'm going back to this letter here, and I'm starting now with let's say X. Okay, uppercase X. Going back to Conqueror, compile, run. Uppercase X is lowercase, and you see the conversion was effectively done. So we are done with this exercise.